Smoke bombs are explosives that emit a lot of smoke when reacted and are in the same category as fireworks. Their most common use is in the military as weapons of concealment. In our lab, we experimented with the ratios of potassium nitrate to sugar, the two reactants, to see how it affected the duration of smoke emitted, as well as the thickness of smoke emitted, to find the optimum ratio that would create the best smoke bomb for real-life purposes. Our original hypothesis was that if there is a larger ratio of potassium nitrate to sugar, then smoke should be emitted for a longer time, because in the reaction equation, more potassium nitrate is needed, and having a smaller ratio would make sugar a limiting reactant. It was not until we did the experiment, however, that we realized that the ratio in smoke emit duration would have an inverse relationship and have a point midway that would have thick smoke as well as having adequate time to conceal someone. For our experiment, the independent variable was the ratio of potassium nitrate to sugar, and the dependent variable, the one we measured, was the amount of time that smoke was emitted from the smoke bomb. Variables we controlled included the heat of the hot plate, which we kept between 250 and 300 degrees Celsius, the time on the hot plate, and the total amount of substance per smoke bomb, as well as the distribution of substance on the hot plate and cooling time. In total, our experiment required 130 grams of table sugar and 190 grams of potassium nitrate. We used 2 hot plates to cook the bombs, and each ratio was done in an aluminum container with aluminum foil, and there are 8 of these in total. We used lighters, stirring rods, and a timer as well. We first turned the fume hood on because the smoke bomb needed to be cooked and prepared in the fume hood, so in the event that it should blow up accidentally, the ventilating system would remove the smoke. Hot plates were placed in the fume hood and were used as a heat source to cook the bomb. These hot plates were turned to 250 degrees Celsius to 300 degrees Celsius so that the potassium nitrate and sugar that was being heated would not overheat while still being able to liquefy and melt together. While the hot plates were heating up, the potassium nitrate and sugar were massed according to their relative ratios, which are specified in the data table. 2 massings were done for each ratio because there were 2 trials. Each ratio of sugar and potassium nitrate was put into a separate aluminum container that each had their own label with the ratio on it. So after massing each mixture, we had to use a mortar and pestle to crush all the rocks of the potassium nitrate so that there would be more surface area and it would be easier for it to react. Then the 2 aluminum trays were put on the hot plates, which are already preheated in the fume hood, and they were continuously mixed, and so that way there would be even distribution and liquefying of the mixture. After everything liquefied, we took the aluminum container off the hot plate and folded it so that the potassium nitrate and sugar mixture would melt into a ball when cooled. The bomb was lit with a lighter on the fuel because the fume hood could not be closed quickly enough, and the smoke emitted could possibly cause the fire alarm and smoke detector to be set off. To light the smoke bomb, the lighter was turned on and held on a specific area on the bomb until it caught fire and released smoke. It was not safe to stay too close to the bomb after it was lit, because gases that could harm the respiratory system were emitted. For each ratio, the duration of smoke emitted was measured and the thickness of smoke observed and recorded in the data table after watching the video recording. The procedures did adequately address the purpose, and we were able to collect data that allowed us to see the relationship between the ratio of potassium nitrate to sugar and the duration of smoke emitted from the smoke bomb, as well as the thickness of the smoke. If we were able to do more trials, we could have ascertained to what the duration was, and for some durations that varied, we could only estimate as to the approximate.